Hello future engineers, there is another video in differential calculus, particularly on finding the second derivatives and of course employing techniques of differentiation such as the basic derivative formulas and chain rule. So there are 6 exercises in this video and I hope that you can follow the explanations, recall the basic derivative formulas and the solutions. So for number 45, I'll solve this in detail. I'll let u be x squared plus x plus 1 so that the derivative of u with respect to x, because the original variable is x, is 2x plus 1. du dx is 2x plus 1. So that this is in the form y equals u squared. So that dy dx is 2u du dx. And substitute the value of u, which is quantity x squared plus x plus 1, then du dx 2x plus 1. So next, second derivative, we have derivative of product. So second derivative of y with respect to x equals 2 times quantity. Consider this as the first factor, x squared plus x plus 1. The derivative of the second is 2 plus second 2x plus 1, derivative of first 2x plus 1. So simplifying, y double prime is 2 times quantity 2x squared, 2 times quantity 2x squared plus 2x plus 2 plus 4x squared plus 4x plus 1. So 2x plus 1 times 2x plus 1 or 2x plus 1 quantity square is 4x squared plus 4x plus 1. Combining like terms, so y double prime is 2 times quantity 6x squared plus 6x plus 3. And finally, because 3 is common, let's factor out 3. So this becomes 6 times quantity 2x squared plus 2x plus 1. So y double prime is 2 times 3 quantity 2x squared plus 2x plus 1. So that's the final answer, y double prime 6 quantity 2x squared plus 2x plus 1. So let's proceed to number 46. This is derivative of product. So y prime equals first x, derivative of second 3 times quantity 2x plus 1 square times 2. Then plus second quantity 2x plus 1 cube times 1. So we factor out the common factor, which is 2x plus 1 square. So y prime is 2x plus 1 square, then times quantity 6x and quantity 2x plus 1. So 6x for the first term here divided by common factor is 3 times 2 times x, so 6x. Then second factor 2x plus 1 cube divided by 2x plus 1 square is 2x plus 1. So y prime is quantity 2x plus 1 square times 8x plus 1. Then for the second derivative, we have derivative of product. Y double prime equals quantity 2x plus 1 square times 8, derivative of second, plus second 8x plus 1, derivative of first 2 times quantity 2x plus 1 raised to 1 times 2. So simplifying, y double prime equals 2x plus 1, which is common. Then this first term is, this is the second term, so this is the common factor 2x plus 1. So what is left in the first term is 8 times 2x plus 1, and in the second, this second term divided by common factor is 4 times quantity 8x plus 1. So simplifying, y double prime equals quantity 2x plus 1. This is 16x plus 32x, 48x plus 8 plus 4, 12. So y double prime is 2x plus 1 times quantity 48x plus 12. So 8 times 2, 16, plus 4 times 8, 32, 32x and 16x, 48x. 8 times 1, 8, plus 4 times 1, 12. So that's why we have plus 12. So finally, the second derivative, because 12 is common, is 12 times quantity 2x plus 1 times quantity 4x plus 1. So that's it for the problem 46. We now proceed to 47. Imagine this is derivative of square root of u, which is our guide, derivative of u divided by 2 square root of u. Derivative of u, derivative of 2ax minus x squared is 2a minus 2x, and in the denominator 2 square root of 2ax minus x squared. So that's the first derivative. Y prime equals 2a minus 2x all over 2 square root of 2ax minus x squared. So take note that we can cancel 2. So that would be y prime equals a minus x over square root of 2ax minus x squared. Then for the second derivative, we have derivative of ratio, which is denominator. Y double prime equals square root of 2ax minus x squared, derivative of numerator negative 1, minus numerator quantity a minus x, derivative of denominator is the same, because this is the derivative of the denominator, square root of 2ax minus x squared, the original. And we just copy this, because this is supposedly the derivative, but after we cancel out 2, this is the result. So times quantity a minus x all over square root of 2ax minus x squared all over denominator square, which is quantity 2ax minus x squared. So cross multiply, we have negative of quantity 2ax minus quantity 2ax minus x squared, then minus quantity a minus x squared all over quantity 2ax minus x squared raised to 3 halves. Simplifying the numerator, we have negative 2ax plus x squared minus quantity a squared plus 2ax minus x squared. A squared plus 2ax minus x squared, because this is all over denominator, which is 2ax minus x squared raised to 3 halves. So a minus x quantity square is a square, so negative of a square. The middle term is 2ax positive 2ax times negative, negative 2ax times negative, so positive 2ax. Then the last term is x squared, negative of x squared, negative of x squared. So we can cancel out negative 2ax, x squared. So the final answer, y double prime, is negative a squared all over quantity 2ax minus x squared raised to 3 halves. So that's for 47. We proceed to 48. We rewrite this as x equals quantity 1 minus t squared to the negative 1 half. And we apply power formula. So therefore, dx dt is negative 1 half quantity 1 minus t squared to the negative 3 halves times negative 2t, the derivative of negative 1 minus t squared. So cancel out negative 2 and negative 1 half. So this becomes dx dt is t quantity 1 minus t squared to the negative 3 halves. So for the second derivative, we have derivative of product. D squared x with respect to t, second derivative is t quantity 3 negative 3 halves 1 minus t squared to the negative 5 halves times negative 2t, plus second 1 minus t squared to the negative 3 halves derivative of first one. So we simplify first, cancel out negative 2t and negative 1 half t. So this is 3 quantity, second derivative of x with respect to t is 3 quantity 1 minus t squared to the negative 5 halves, then plus 1 minus t squared quantity to the negative 3 halves. Common factor is 1 minus t squared quantity raised to negative 5 halves. So let's factor that out. Then we have 1 minus t squared raised to negative 5 halves times quantity 3t squared. then plus quantity 1 minus t squared to the 1, or 1 minus t squared alone. So the second derivative is, this is 1 plus 2t squared. If we simplify this, so 1 plus 2t squared, and we bring this down and write this as 1 minus t squared quantity to the positive 5 halves. So the final answer, second derivative of x with respect to t, is 1 plus 2t squared over 1 minus t squared quantity to the positive 5 halves. So let's continue with exercise 49 from Love and Rainville's book. We have already finished 45 to 48. So let's proceed to problem 49. This is derivative of ratio. So dx dt equals denominator t squared times derivative of numerator 2 times quantity 1 plus t raised to 1 times 1 minus numerator 1 plus t quantity squared times 2t all over denominator square, so that becomes t to the fourth. Since t is common, let's cancel out t. So dx dt equals 2t quantity 1 plus t, then 2 times 1 plus t squared all over t cubed after we cancel out t common. Simplifying the numerator or factoring out 2, so we have dx dt equals 2 times 1 plus t, common factor, over t cubed. Then quantity t minus quantity 1 plus t, then all over t cubed. So simplifying, dx dt is 2 quantity 1 plus t times negative 1, so that's negative 2 quantity 1 plus t all over t cubed. So we have derivative of ratio, or we may simplify this into negative 2 over t cubed, then minus 2 over t squared. And we write this as negative 2t to the negative 3. So dx dt negative 2t negative 3 minus 2t to the negative 2. So second derivative is positive 6t to the negative 4, and plus 4t to the negative 3. Finally, making the exponents positive, so the second derivative of x with respect to t would be 6 over t to the fourth plus 4 over t to the cube. So that's it for problem 49. We then proceed to problem 50, derivative of product. So y prime equals quantity 2x minus 1 cube first, derivative of second, times 2 quantity x plus 2 raised to 1 times 1, plus second quantity x plus 2 squared, derivative of first 3 quantity 2x minus 1 squared times 2. So simplifying, common is 2x minus 1 square and x plus 2. 2 times quantity 2x minus 1 square times 2 and x plus 2. 2 times 2x minus 1 square times x plus 2. So first term here divided by this common factor. The result is 2 quantity 2x minus 1 raised to 1, or simply 2x minus 1. For the second term divided by this common factor here, the result is 3 times quantity x plus 2. Simplifying, y prime equals 2 times 2x minus 1 square x plus 2, then times 5x plus 5. So 2x and 3x, 5x, negative 1 and 3 plus 2, 3 times 2, 6, 6 minus 1, 5. Factor out 5, so y prime is 10, quantity 2x minus 1 square, x plus 1, and x plus 1, x plus 2, and x plus 1. Let's combine this. Let's simplify. So y prime is 10 quantity 2x minus 1 square, then times quantity x square plus 3x plus 2. So that we have derivative of product again, factoring out this constant. So y prime equals 10 quantity first 2x minus 1 squared, the derivative of second 2x plus 3, plus second x squared plus 3x plus 2, derivative of first 2 times quantity 2x minus 1 times 2. So y double prime is 10 quantity 2x minus 1 square 2x plus 3, then 4x squared plus 3x plus 2, then 2x minus 1. So 4 is 2 times 2. Then common to this inside terms is only 2x minus 1. So y double prime equals 10 times 2x minus 1, common, then quantity 2x minus 1 and 2x plus 3 in the first term. In the second term is 4 times quantity x squared plus 3x plus 2, or simply 4 times quantity x squared plus 3x plus 2. Let's simplify inside. So y double prime is 10 quantity 2x minus 1, then 4x squared, quantity 4x squared, 6x minus 2x is 4x, then minus 3. 4x squared plus 4x minus 3, then plus 4x squared plus 12x plus 8. Combining like terms inside the brackets, y double prime is 10 quantity 2x minus 1, then 8x squared times 8x squared plus 16x plus 5. So that's the final answer. Let's just highlight it. Y double prime equals 10 quantity 2x minus 1, then 8x squared plus 16x plus 5. So that's it for this video. I hope that you were able to follow, listen carefully, and follow the explanations and the solutions.